We're Michael and Dhruv, and today we're going to be presenting about finding associations between firms using media coverage data.
So a bit of background, a company like Apple in today's day and age is in a lot of different markets at the same time. And it can be represented as several different kinds of companies, for example, software, hardware, entertainment, and financial, depending on the context. So furthermore, our hypotheses are that companies that are in the same industry will have similar co-occurrence patterns because they'll be mentioned in terms of competition in the same headlines. Furthermore, we also expect conglomerate companies to have a very high degree of centrality since they will be able to connect between many different industries. Also, the closer the relationship between the company, either as a partner or as a competitor, will generate, we believe, to be a stronger connection between the company nodes. And also, because certain companies are not really mentioned in the media cycle, certain nodes will probably be disconnected from the network.
To collect the data for this project, we obtained a list of all S&P 500 companies from Lazard. We pre-processed them so that it's not biased to financial data on Google. And lastly, we scrolled Google to pull 100 Google News headlines for each company.
So in terms of our models, we did a few different things. So each headline was first parsed for other company co-occurrences. And then what we did was we matched these companies with their corresponding sector data provided by S&P. And then a t-SNE plot was generated from that co-occurrence matrix in which each point was colored depending on the sector that it's in. And from that, a network graph was created using the co-occurrence matrix. So when we look at the t-SNE plot, we sort of see at first there's many outliers. So the first thing we did is we processed them, we got rid of them. So now we can sort of see the central mass of points and industry clusters begin to emerge. For example, on the bottom right, we see that the information technology sector in blue occupies a certain space. Also toward the bottom left, in magenta, you have the healthcare industry. And in addition, in slightly off-center, you have consumer staples in light blue as well. So now when you look at this center cluster, we sort of see a separation between the rest of the companies. We expect that this is because of an investor type roundup, and all the different companies are mentioned in the same headline.
We then created a network graph using these co-occurrence matrices. Essentially, if there was a positive co-occurrence, we added an edge between those two networks. With the co-occurrence matrix, we can see that the network graph is very populated and too clustered. So we came up with a network graph for just the information technology industry. Out here, the weights of the graph, if there's a thicker line, that means there was a stronger co-occurrence between those two companies. Next, we also developed a word embedding and cosine similarity based model. We obtained word embeddings for all words in each of the headlines using the 300 glove encodings that were trained on 6 billion tokens. We then calculated sentence level embeddings by taking the mean of all these word embeddings. And lastly, we calculated a similarity score using the cosine similarity metric. Next, we created network graphs just like the co-occurrence matrices using similarity scores and a benchmark for each similarity for each headline had to pass a certain similarity score. So out here is a similarity score graph for using the glove embeddings, and here we can see it's a lot more clustered and is able to capture a lot more relations and edges. To have it a little bit more clear, we display the information technology sector, and out here once again it's still a lot more clustered.
So now when we look at the co-occurrences and the word embeddings combined, we sort of see certain patterns approach. First, when we looked at our connectivity coefficient, which we defined, we sort of defined it as the average number of edges per node. So we see that for glove, because it is much more robust, and since co-occurrence matrices are more sparse, embeddings are pre-trained and capture context much better, so they will generate edges much more frequently. We can also see the fact that there's no isolated nodes for the glove model. Now, in the IT industry in particular, we notice that the tech industry is actually more connected as a whole per company, and that we see a similar pattern.
Moving forward, we want to experiment with various things like getting more metrics related to the graphs, hypertune our coefficients, thresholds, experiment with character level embeddings, try building a rapid network using both co-occurrences and glove graphs, and lastly, try experimenting with the autoencoder model of pre-trained Google autoencoders.
Thank you so much for your time.